This is the fourth video helping you to distinguish between the four different kinds of chemical reactions. And here we're going to talk about ion swaps, either acid-base or precipitation reactions. Here's your worksheet. Identify by type the following reactions: aqueous silver nitrate reacting with aqueous sodium iodide to form solid silver iodide and aqueous sodium nitrate. Acetic acid reacting with sodium hydroxide aqueous to form liquid water and sodium acetate solution. Sodium carbonate reacting with hydrochloric acid, there will be 2 moles of that, to form 2 moles of sodium chloride in solution, liquid water and carbon dioxide gas. And sodium cyanide aqueous reacting with hydrochloric acid aqueous to form hydrogen cyanide gas and sodium chloride solution. We'll talk the first one first. Silver nitrate reacting with sodium iodide in solution to form solid silver iodide and aqueous sodium nitrate. This looks like a classic precipitation because a solid is formed, and it is one. But we need to look more closely at what is happening in all ion swap reactions. Silver nitrate solution is really silver ions and nitrate ions in water, each ion surrounded by water. Sodium iodide solution is really sodium ions surrounded by water molecules, and iodide ions surrounded by water molecules. So those ions surrounded by water molecules are swimming around together. And you can magnify it and it kind of looks like this. The blue squiggly lines are the water molecules that surround them. And the cations bounce off the other cations up here, and the anions, negative ions, bounce off the other negative ions. Moreover, the nitrate ion is not attracted enough to the sodium ions to form a precipitate. They just move around the solution. But when a silver ion gets close to an iodide ion, the attractive force is extremely strong, and strong enough that they form a low energy ionic bond and push the water molecules out of the way. Then all the silver iodide groups clump together and fall to the bottom as a low energy precipitate, which you see over here symbolized with a kind of a crystalline structure of silver iodide. The sodium ions and the nitrate ions continue in the solution. Ion swaps happen in aqueous solutions, and they happen between soluble salts or soluble acids and bases in general. The form looks like this. Aqueous compound AB reacts with aqueous compound CD to form compound AD and aqueous compound CB. The question mark stands either for S, if you're making a precipitate, a solid, or it is an L for water formed in an acid-base reaction. In general, C and B are spectator ions that continue in solution as C with some positive charge aqueous and B with some negative charge aqueous. So let's look again at the silver nitrate sodium iodide reaction. We just finished going over this one and kind of pictured the ions. The reaction is a precipitation because a solid is formed. It is already balanced. The products, however, are really silver iodide solid, aqueous sodium ions, and aqueous nitrate ions, which are spectators. The net ionic equation omits the 2 spectator ions, and so we have only silver ions aqueous reacting with iodide ions aqueous to form solid silver iodide. This is the way a net ionic equation is shown for this kind of reaction, the precipitation type of ion swap. Acetic acid reacts with sodium hydroxide to form liquid water and aqueous sodium acetate. The reaction is, of course, an acid-base reaction. It's already balanced. The products, however, are really water, liquid water, sodium ions in water, and acetate ions dissolved in water. The ionic equation then omits the spectator ions, sodium and acetate, and all you see here is hydrogen ion plus hydroxide gives you liquid water. This is the general form for the net ionic equation of any acid-base reaction that forms water. Here is another reaction. Sodium carbonate reacts with 2 moles of hydrochloric acid to form 2 moles of sodium chloride solution, liquid water, and carbonate. This is a fizzy reaction that sometimes is used in the old middle school volcano. Since there are 3 products, this may look strange, may not look like an acid-base reaction, but it is an acid-base reaction. The water and carbon dioxide come from the second product that's formed, carbonic acid, H2CO3. That is a very, very unstable acid and breaks up into water and carbon dioxide. You'll know that as soda pop, carbonated water. This reaction, sodium cyanide reacting with hydrochloric acid, form hydrogen cyanide gas and sodium chloride aqueous. May be a bit confusing since there's no water product. It is, however, an acid-base reaction. The cyanide ion is acting as a base instead of hydroxide, and the hydrogen cyanide gas produced takes the place of a water product. So this is an acid-base reaction, even though it's a little unusual since cyanide is there instead of hydroxide. Now concluding this presentation and this series of 4 presentations, ion swaps. In all cases there are 4 ionic reactants, 2 cations and 2 anions. One cation-anion combination forms a compound that has low energy. It might be water, it might be a precipitate. The energy is so low that the energy of the water molecules can't break the compound up. Typically that's either a precipitate or it's water. And here's something to always watch for. In an ion swap, oxidation numbers never change.